Hello and welcome to this section of the MATLAB tutor. We're going to close our discussion of matrices by discussing how to use matrices in the context of symbolic math toolbox. And that's kind of what we've been doing for all of our lessons up until this point. Before we do that, I wanted to quickly show you one useful topic that is worth mentioning, and that is how to calculate a matrix with random values. You know, if you just type in the rand command, we've talked about how you can get random numbers. We've talked about how you can type in one row and 3 columns and pass that to rand and you get like a vector. Well, you can also create a matrix of any size you like. 3 by 3 matrix would be passing random with 3 rows and 3 columns. You can do 5 rows and 3 columns and calculate random numbers. Now everything in here will be between 0 and 1, so for whatever reason, if you needed random numbers between 1 and 10, then you would just do 10 times random, 4, 5. And then you'll have random numbers between 0 and 10 because you're just scaling the random number generator multiplied by 10 and so on. So that's useful for you to know. It's not something you use all the time, but occasionally you'll need to initialize a calculation with random data just depending on what you're trying to do. Next, we want to talk about the important topic of symbolic math. So, up till now with matrices, it's all been numbers, right? We put numbers in, we calculate things, it's numbers, numbers, numbers. Now, symbolic math, we're talking about expressions, algebraic expressions. We don't want to deal just with numbers anymore. We want to deal with x's and y's. So we need to define our variables. So we use the symbs command to define symbolic variables. So let's define one called x and one called capital A. And let's do another one called capital B even, okay? So what we have here is 3 variables created. You can see that they're all symbolic, symbol, symbol, symbol. Capital A and capital B are going to be some matrices I'm going to create, and X is going to be something I'm going to put inside of the matrices, and you'll see kind of what I'm talking about in a minute. So let's calculate and create matrix A. Remember, matrix A is now a symbolic matrix. And since the variable X is also a symbol, I can do things like this. X to the second power space X minus 3. That could be the first row. The second row could be X to the second minus X, and then space, and then you can just do X or something like that. So we'll close that off, and you can see the matrix here right in front of us. So what we have for the first row is x squared and x minus 3, and for the second row we have x squared minus x, and then we have the element x. Now, one thing I want to point out is that when you're using symbolic functions or some symbols in MATLAB and you're using matrices, the formatting is a little bit different. Notice that MATLAB is now putting brackets on the output, and notice it's putting a comma. This is to kind of make sure you're not confused, because if you didn't put a comma here, you might think it's x squared times x minus 3 or something. So what this is telling you is the first element is x squared, and then x minus 3, and then x squared minus x, and then x. And this is a 2 by 2 matrix we're calling A. And we can create another matrix B, and we can kind of do the same thing. We can just set it up and say, okay, the first row is going to be x, and then after that will be, let's do x to the 4th power minus x, and then the next row could be, again, x squared, and then let's just say x plus 4 or something like that. We'll close it off. So again, we have another 2 by 2 matrix we're calling B. Notice that matrix A and B have been updated. 2 by 2, it's a symbol matrix, symbolic matrix, 2 by 2. And notice now that MATLAB's able to handle these expressions as algebraic entities. They're not numbers, they're symbols. So everything we do in terms of matrices is going to try to keep everything simplified and manipulate them in the rules of algebra, but use them as these symbols. So for instance, I can do A plus B, and I can add these guys together, and it's going to add them element by element. If x squared plus x is going to give me x squared plus x, and it's going to go element by element and add these guys together. I can subtract A minus B, and I'm going to take A and I'm going to subtract x squared minus x for the first element, and then I'm going to have x minus 3 minus x squared, x to the 4th minus x, and I'm going to get this guy for that element there, and I'm going to go element by element and subtract. I can take 2 and multiply it by matrix A. I can take 10 and multiply it by matrix B, and I'm going element by element just like you do if it were numbers, but it's treating everything exactly because these are symbols. So let me put matrix A and matrix B back up here. I can also multiply these matrices because they're both 2 by 2 matrices, A times B. I can multiply these together and it's going to use the rules of matrix multiplication across and down, just like you typically would expect, to calculate a resulting matrix that looks something like this. So you can see it's doing all the matrix multiplication for you. Now you can also do A times B, but if you put a dot in front, then it's going to treat it as element by element multiplication, which is what we've talked about always happens when you put a dot in here. And so we get this. So now we have x squared times x for the first element, and that just gives us x to the third. This x minus 3 times this stuff is going to give me this expression here. So this one is doing it element by element. This way is doing it in the true matrix multiplication way, where you go across and down and you have to sum up everything. So let me put matrix A and matrix B back up there. You can also do transposes. So here's the transpose of matrix A. And you can see that we've got some conjugates going on here because it doesn't know, by the way, what x is. X is a symbol. X could be imaginary, x could be real. MATLAB's not going to assume anything. So when you do some of these operations, you might see a conjugate occasionally pop up, and that's just because of the fact that it doesn't really know if these are real or imaginary entities because they're symbols. And we can also do things like take the determinant. We can take the determinant of matrix A, and it's going to do it in exactly the same way that you would do it by hand. It's going to, since this is 2 by 2, it'll multiply these together, and then it'll multiply these together and subtract them, and you'll get the determinant of matrix A. And if this were a larger matrix, it would do all of that math behind the scenes and calculate that determinant. It can also take the inverse of these matrices, and you'll get some large mathematical expression, because the inverse of a matrix is kind of a complicated thing to calculate even by hand, and so when you have symbols involved, it makes it even more interesting. And you can take the trace of this matrix as well. So let me actually clear the screen so you can see. So the trace of matrix A is going to be the sum of the diagonal elements. So this is x squared plus x, and there you go. So that's about all I want to say about the symbolic math toolbox with matrices. I mean, we've learned in excruciating detail how to manipulate matrices, how to multiply them, how to do element by element multiplication, how to do inverses and determinants and eigenvalues and everything. And we've learned that MATLAB does it all easily. The only difference here is I've created a symbol, so MATLAB knows to treat this as an algebraic object instead of just a number. And so when I create this matrix, I can basically apply all the functions to it. It's just going to manipulate them as if they're just algebraic expressions, and that's exactly what you want it to do. If you changed matrix A, and so you don't have to have x's here, I could put a symbol 3/4 here. We've talked about how to make symbols with fractions. So I could put 3/4 as a symbol, and 1/2 as a symbol, and 7/8 as a symbol. If I had a matrix with a lot of fractions, I could do it that way, and then when I get the answers, I could easily turn up with an answer that has fractions. So for instance, I could say fraction. Well, let me just do it like this. We'll do matrix J for Jason, right? We'll say matrix J. We'll do let's do sims J. So we'll create a symbolic matrix there, and we'll say, so this guy, I'm going to call it symbol 1/2, symbol 2/5. That's the first row. And then the next row, I'm going to have a symbol. I'm going to call it 4/5. And then I'm going to have another symbol. Let's just put 1/2 back in there. So you see, now I've created a matrix with numbers. The only difference is I put symbols and wrapped everything in symbols, so MATLAB knows that these are now symbols. So I have 1/2, 2/5, 4/5, and 1/2. So if I do something like take the determinant of J, then I'm going to get a fractional answer back. It's going to try to keep it exact. It's not going to convert any of these to decimals and truncate anything. If I do an inverse of J, I'm going to get some matrix back that's going to have fractions. So when you're dealing with Symbolic Math Toolbox, it doesn't just mean you have to have x's and y's. It means maybe I have a lot of fractions. Maybe I have a lot of pi's. I could easily have a fraction that has pi everywhere, and I would do that as a symbol so I could see what the final answer is in terms of pi. So it's very useful. So make sure you understand how to use the Symbolic Math Toolbox. Make sure you understand how to define them, how to put the stuff in there, and how to interpret the results. And make sure you understand how to use matrices in general with MATLAB, because I think you can see that it really does handle everything in terms of a matrix. So as we go forward, it's going to be easier for you to do everything as we go forward if you understand how MATLAB really handles matrices.